Hi everyone. I apologize for having to be gone today, but the team is out of town and so that's where I have to be. Yesterday we did section 2.2 in the book, which was on odd and even functions and then piecewise functions. If we want to start by having our homework out, you can pause the video to make sure that everyone has it out, but I'm going to continue forward assuming that we have it out and are ready to go. I'm just going to read off the answers. So in 2.2, question 13a, x equals 0, there's a relative maximum at 4. B, x equals -3 or +3, and there's a relative minimum at a y value of 0. 17 is an odd function, 19 is neither, 21 is even, 29 is even, 31 is odd, and 32 is neither. 33 has quite a few parts to it. A, the domain goes all real numbers, -infinity to +infinity. B, the range, the lowest y value is -4, then it goes up, so the highest y value is technically +infinity, it's unbounded. C, there are two x-intercepts at 1 and 7. D, the y-intercept is 4. E, it goes from 4 to +infinity. F, from 0 F is 0, 4. G, -infinity to 0. H, x equals 4. I, y equals -4. J, f of -3 is 4, so when x is -3, y is 4. K, f of 2 equals -2, so when x is 2, y is -2. F of 6 is equal to -2, which means when x is 6, y is -2, and then L is neither. 37, three values are -1, 7, 19. 47a, the piecewise function looks like so. You have to graph the two lines individually. The one on top is only true for x values less than -2. The one down below is only true for x values that are equal to -2 or to the right. The range is unbounded. It goes all the way down and all the way up, so we'd say -infinity to +infinity. And those are your answers. If you would, please have out your note packet to 2.3. And we're going to start there. Today we're reviewing properties of slope and ways to write equations of lines, and then properties of interpreting data that model a linear relationship. So when someone plots data, they usually do so in a type of graph called a scatter plot. A scatter plot is a graph used to determine whether there is a relationship between paired data. When you pair data and you graph it, if you're looking for a linear relationship, there are three things that can happen. It can have a positive correlation. That means when x is increasing, y is increasing. It can have a negative correlation, which means that as x is increasing, y is decreasing. That line of best fit would have a negative slope. Or it might have no relationship at all, just a random smorgasbord of points. If I were in class today, I'd ask us to brainstorm a situation that has a positive, negative, and no correlation. An example of a positive correlation might be the temperature and the air pressure inside a tire, because as the temperature increases, so does the air pressure inside the tire. A negative correlation might be elevation and oxygen levels. As your elevation increases, your oxygen level would decrease. Something that might have no correlation might be height and GPA. Those that have no correlation, so it would be a smorgasbord of points. We're going to start with a data set. That's where people actually start to look for trends and get equations for functions. So here is data on the Earth's average global temperature. How much has the temperature changed per year between 1960 and 2000? So I'm going to circle those two data points, 1960 and 2000. So my two data points, they say the decade's 1960s. We'll just call that the year 1960 though. Temperature average on Earth was 57.18. And the other year is 2000, and the average temperature is 58.12. I want to see how much it's changed. So how much has the temperature changed? Well, 58.12 minus 57.18. I see that it has gone up by 0.94 degrees. And it's done so over a period of 2000 minus 1960 shows me it's done that over a period of 40 years. So this top value is how much the temperature's changed. This bottom value is the time period, that's over 40 years. If I actually take 0.94 and divide it by 40, I get a value of 0.0235. That is actually degrees per year. That's how much the temperature is going up by. How do I know it's going up? Because it's a positive increase. So that average change actually has a term in mathematics. We call it the slope. The slope of a line that goes through 2 points, we'll call the very first point x1 comma y1. The 1 just means the x coordinate of the first point, and then if x2, y2 means the x-coordinate of the second point and the y-coordinate of the second point. When I'm talking about slope, I'm talking about the change in y, the change in my output divided by the change in my input. If it's a graph, it's rise over run. Rise is the vertical change, run is the horizontal change. I always do y2 minus y1 because I always do the new value minus the old, just like I did here, 58.12 minus 57.18. So this would have been x1, this is y1, this would have been x2, and this would have been y2. And what I did was exactly what slope is, y2 minus y1 over x2 minus x1. When I graph a line, there are four things that can happen. I can have a positive slope. That means it's increasing going left to right. I can have a negative slope, which means it's going down left to right, decreasing. I can have a zero slope, which means I have a horizontal line because my vertical change is zero over whatever my horizontal change would be. My horizontal change could be anything, and 0 divided by anything is still going to be 0. And then if I have a vertical line, I have an undefined slope because my horizontal change would be 0, and if I try dividing by 0, I get an undefined value. So a vertical line has an undefined slope, a horizontal line has a slope of 0. Leading to the next part is going to be writing equations for lines according to that average rate of change and a point. So let's say you're paid $25 for each lawn that you mow next summer. After mowing 8 lawns in total, you now have $275 in your bank account. If you were to mow 14 lawns in total, how much would you have in your bank account? So this is how I would think about it. I would say, well, if I'm going to use variables, I should probably write what they represent. Y is going to be my money in total, and x is going to be the number of lawns that I've mowed. So if I were to write an equation for what I know the money that I had at some point in time was $275. Plus, I get an extra $25 for every lawn that I've mowed. Well, this $275 was after I'd already mowed 8 lawns, and I want to know, what if I mow 14 lawns in total? Well, how many extra lawns do I need to be paid for? Well, that's 14 minus 8. I need to be paid for 6 extra lawns. So I would say 275 plus 25 times 6. 25 times 6 is 150, and 150 plus 275 would be $425. That's how I would think about it. I would say I have 275. That's after I'd already mowed 8 lawns. If I want to know how much, if I had 14 lawns in total, I need to be paid for 6 extra. What if I had done the same question, but I want to know, what if I were going to do 21 lawns in total? So I would say at some point in time, I know I had $275, and I get $25 for every extra lawn that I mow. How many extra lawns do I need to be paid for? Well, that 275 was after I'd mowed 8, so I need to be paid for 21 minus 8, which would be 13 extra lawns. So 275 plus 25 times 13. 275 plus 25 times 13 gives me $600 is how much I would have in total after doing 21 lawns in total. How much would I have in my bank account after mowing X lawns in total? I don't want to do this process over and over again. Can I write an equation? Well, here's my equation. I would say the money I have is $275, plus I get paid $25 for every lawn, and X represents lawns, past the 8th one. Now I can put in any value. If I put 21 in there, it will make this guy. I could say, what if I did 40 lawns in total? I put 40 in here. 40 minus 8 tells me I need to be paid for 32 extra lawns. So this value right here tells you how many passed the value that you knew. So there would be my general equation. Now I could put any total number of lawns in there, and I would get a value. This, what we just did, is we just wrote an equation in what's called point slope form. It's actually a modified point slope form because the rest of the world writes point slope form with y minus y1. What we just did is we solve for y. We have our y coordinate on the other side. So to write an equation for a line, if you're given a point and the slope, the rate of change, you do it in the following way. You say your y is equal to your y coordinate. In our case, this was the $275 we knew existed at some point in time, plus or minus, depends on what your slope is, your slope for every x past the x coordinate that you knew. So these guys right here, these are your variables, the items I've underlined in purple. These values right here that I'm circling in blue, these are your coordinates of the point that you know, and this is the slope, your rate of change. The rest of the world writes it like this: y minus y1 equals m times the quantity x minus x1. It's the exact same thing we were doing above, they just haven't solved for y yet. You would add the y1 over to the other side. So example of doing a problem. What if I ask you to write an equation giving the following information? So if I give you a slope and a point, this is how I would write it. I would start by saying y, well the y coordinate is equal to what? Well this is the x coordinate, x1, y1, because there's only one point. So I would say my y coordinate is -1. How does my line change? Changes by going up 2 over 3 for every x past the fourth coordinate, just like we did in the lawn example for every lawn past the eighth one. So there would be my equation. What if I give you 2 points? Well, the very first thing you need to do is find the slope. So x1, y1, x2, y2. I would do 12 minus 6, y2 minus y1 over -4 minus -2. That's going to give me 6 over -4 plus 2 is going to be -2. I get -3. So my slope is -3. Now I need to pick a point. It doesn't matter which point I choose. I'll choose the second one just to show it really doesn't matter. So I would write my equation as, draw a line. My equation would be my y coordinate of my point is 12. My line changes by going down 3 over 1, but I just write -3. I don't need to write it as a fraction. It does this for every x past -4. How do we clean this up? If it's minus a negative, we would just write it as a plus. So we'd say y coordinate is 12 minus 3 for every x past a negative is +4. And that's how you could see it written in point slope form. Going to give you a chance to try. So your job is to write an equation of a line that goes through the points -3, 4 and 2, -2 in some point slope form. If you want to write it in the modified or in the regular, feel free to do so. But pause the video now, give people maybe a minute and a half to try it, and unpause it once everyone's had a chance to try. Okay, let's see how we did. First thing you need to do is find the slope, which would be -2 minus 4 over 2 minus a -3. That's going to give you -6 over 1, so your slope is -6. Now pick a point. I'll do the first one. Y is 4, down 6 over 1 for every x past -3 will make +3. And you'd be done. If you wrote it with the other point, it would be this. Y is -2, down 6 over 1 for every x past 2. So if you wrote it with the other point, it looked like that. These are actually the exact same equation. If you typed them into a graphing calculator, they'd make the exact same line. They just start at a different starting point. So that's one way of writing the equation for a line. The second way is actually the most common, and it's called slope-intercept form. Why is it called slope-intercept? Because the point that we're choosing is a very specific point. It is the y-intercept. So the slope-intercept form for the equation of a non-vertical line that has slope m and y-intercept b is y equals mx plus b. Example, graph y equals -1/2 x plus 4. My slope is -1/2. My y-intercept is 4. I start at a point of 4, and I go down 1, right 2, because that's my slope. This is my vertical change. My horizontal change is +2. Down 1, right 2, down 1, right 2. Have a few points. I can sketch in my line. It's the same as going left 2, up 1. That would be consistent. So there's the first thing you should be able to do. If given an equation in y equals mx plus b form, graph it. I think we got 2 more to do. Yep. So going back to our global warming data, use the slope we found earlier and another point to write the equation first in point slope and then simplify it to slope intercept. So if I go back and look, what was the slope we found? It was 0.0235. 0.0235. They say to first write it in point slope form. We're going to have x representing years since 1960. Y is the temperature. It doesn't matter which point I choose. Let's do I think we did 1960s and 2000s, so let's use the second point, 2000. So I would say the y coordinate of my point is 58.12. My slope is going up 0.0235 for every year past 1960, or sorry, this is the year 2000, so for every year past 2000, so that would be 40 years past 1960. How do I get it back into y equals mx plus b? I just simplify, distribute this through. I get 58.12 plus 0.0235x, and then I take 0.0235, multiply it by 40, and I get 0.94. I then combine my like terms of number here, and I get y equals 0.0235x, 58.12 minus 0.94 leaves me at 57.18. And you'll notice that that is actually the y-intercept. That would be the y value when x is 0, because 1960 is year 0. The other way you could do this is by writing y equals mx plus b to start, and then substituting in the coordinates of the point to solve for b. So I know my slope is 0.0235x plus b. I know my year that I chose was 2000, so that'd be year 40 for x, and my y value is 58.12 equals 0.0235, put in 40. If I multiply those two values, well, I did that already, that was 0.94 plus b, 58.12, subtract, and I get 57.18 is equal to b. Once I know that, I know the slope, and I can substitute this back in for my y-intercept, and then I have my whole equation is the exact same one I got before. So that's method 2. Instead of writing in point slope, you can write y equals mx plus b and solve for b. Last thing I need to show you is how to graph unique equations for lines. If they give you y equals 3 or x equals 2, just make a table. This says y equals 3, so all my y values need to be 3. Just pick a few points. It doesn't say anything about x, so you can pick any x that you want, 0, 1, 2, 3. Then plot 0, 3, 1, 3, 2, 3, 3, 3. Y equals lines make horizontal lines. Then do one for x. This says x has to be negative 2, but y can be anything. So then substitute values in for y, anything you want, because it doesn't say anything about y. So 0, 1, 2, 3 are easy, and plot those. So I get negative 2, 0, negative 2, 1, negative 2, 2, negative 2, 3, and graph that. So x equals lines will make vertical lines. And that's it for 2.3. I'd either give you the rest of the period just to try problems and have questions ready for me tomorrow. So if you want to, you can leave the video paused on these answers and then just have questions ready for me tomorrow. Otherwise, have a good day.